Hello everyone. This is your instructor, Dr. Rachita Misra, speaking to you on your software engineering course. Today we will be covering the requirements, engineering and use case. The topics that we will be covering today are, as I have written here, the requirements engineering, the what and why of the requirements engineering, and we will also go into what is a good requirement, and we will look into the requirements engineering tasks. And we will look into a specific task, that is the elicitation, some of the techniques into it, and we'll look into the outputs from the elicitation, and specifically we will talk about prototyping. As we have already covered the process for the software engineering, all of you know that requirements engineering is one of its activity. So what is requirement engineering? If you follow these two words, requirement and engineering. So requirement, we mean by requirements a function or a feature or behavior and constraint of the software or any property of the software that we need to provide or we need to fulfill. That means the customer is looking for a particular function, feature, behavior, constraint or property that has to be fulfilled by the software. The software needs to provide those functions, features and behavior so that the users can carry out their business needs. And if you go to engineering, we know that engineering is a discipline of using systematic and repeatable techniques. And it is heavily based on the past experience and certain practices or standards. So when we add these two terms, we get the requirement engineering. That means it includes all the processes that we are using in our software engineering to collect the requirements. That means to gather the requirements for the software product that we need to build, and all the techniques that we will use to analyze it, to document it, to validate it, to manage it in a very systematic manner by using the engineering principles. And as I have just been telling you, it's an important technical activity of any process model. So why we have to do the requirement engineering? What happens if we don't do it in this particular manner that we are going to explain now? The software engineering team, they need to understand the requirement of the user's problem. What do they really need? What is their business need? What is their goal? What are their constraints that they are facing? What is the problem they are facing? Unless we understand the business domain and what they are looking for, it will be very difficult to create a product which will fulfill their needs. And therefore, it is often called, instead of calling it requirement engineering, many people call it very simply, in a very simplistic way, requirement analysis and specification. And it forms the foundation of the design and construction. Design and construction we all understand because we have to create the software. So when we do this design and construction, we need a specification. So requirement engineering actually provides us this specification that we are looking for to convert it into design and construction. And if you don't do a good RE, then there is a risk that the software will not meet the customer's needs. If it will not meet the customer's needs, then it will fail. The customer will not be satisfied. So sometimes what happens that RE is not an activity that can be eliminated, but we can abbreviate it, we can shorten it. So if you see the agile processes that we were looking for, or the incremental method or the evolution method, there the RE is not done at a time, but it is done in parts for every increment. So it is abbreviated, but it is never eliminated, because that is the foundation on which we work. And as you know, it is initiated in the communication phase. When we did the generic process model, we talked of this. We talked of the communication phase. And in the communication phase, we are collaborating with the customer. So when we are collaborating with the customer, at that time, we will be able to do this kind of requirement gathering, the analysis, and also we can do the many of the modeling of the requirements. So what are the characteristics of a good requirement? So now that we know that we have to do the requirement engineering, so let's look at what do we call a requirement as good. First of all, it needs to be clear and unambiguous. That means we should be able to interpret it correctly. Okay, and also we need to have a standard structure so that everybody will be able to understand it. It will be there, clarity will be there, and mostly we try to create one requirement in one sentence. That's a practice, and it should be correct. That means it should relate to the real need, not a fancy, but the actual need of the customer. It should be understandable. That means the functionality and the objective of the requirement should be easily understood. The language should be simple. The structure should be good, and that is why we use models. We will go into the models very soon. And it should be verifiable. That means it should be written, the requirement should be written in such a form, it should be documented in such a form that we can test it, because finally we have to see, when we create the product, we have to see that the requirements are satisfied. So unless it is written in that form, we cannot do it. So the good requirement must have a verifiable characteristic. It should be complete in the sense that we have to take care of all the requirements. There should not be any omissions. Okay, and it should be consistent. When we say it is consistent, that means if you have 3 pages of requirements, then in the first page and in the third page, there may be different requirements given by different stakeholders, and they may conflict. So this conflicting has to be removed. It should be consistent, and it should be traceable. Now, what is traceable? Traceable is a feature by which we can track. So we have to do, this is your requirements. These are all your requirements. And this is the software you have created. You have made the design and you have coded it in some language. In some language you have coded it. And you are putting it on a computer and you are executing it. So we have to see, before we go to the execution, we have to see that each of these requirement is actually converted to a design and converted to a code. And we should also, if we have a piece of code, then we should be able to say that this piece of code belongs to this design and it belongs to this requirement. That is what is meaning by the traceability. So why getting good requirements is hard? Because normally we say, oh, it's a very difficult thing. We have to follow so many techniques and so many methods. Because there is a human element that is involved in getting the requirements. It is not a mathematical formula. It is not a physical attribute that we can measure, but we have to get it from stakeholders. The stakeholders are human beings. They are either users or customers, and they cannot express properly because they are living in their domain, business domain, and they cannot really say how software should look like. So that is the major problem that software engineers face. And not only that, the different stakeholders, they may expect something different. Their expectations may be different. They may have conflicting requirements. Then we have to do some negotiations. We have to put them together, and we have to make them understand. So unless the software engineer understands their requirement, each one's requirement, you cannot do this. So that is another difficulty in getting the requirements. Similarly, the stakeholders express requirements in their own business language, which a software engineer has to convert in the normal language or in a model form or a structured form, which can be understood by all. So that is another difficulty that we find. So there is a communication gap. There is a language barrier between the stakeholders, business people, and the software engineer. And then there are organizational and political factors which may influence, and the requirements may change during the RE process. Not only during the RE process, it may change even after, but during the RE process, that also it may change. And then there may be some new stakeholders. Initially at the inception stage, when you identified the stakeholders, you did not have so many people, but later on, by the time you are completing your requirements and you are going to the design phase, some other new stakeholder may come. Then their requirement has to be taken up. So that is why it becomes very difficult, and you have to follow certain discipline. So let's look at what those discipline is. In other words, what are those engineering tasks that we have to follow during the requirements gathering and requirements analysis. So there are basically these 7 tasks. I have written it here: inception, elicitation, elaboration, negotiation, specification, validation, and then finally the management of the requirements. So at the inception, that means we are starting the requirement engineering tasks. So we have to identify the stakeholders who will be providing us, who will be using the system and providing us the requirements. And we will have to establish a basic understanding of the problem and the nature of the solution. This is a very high level communication that we have to establish. Then we will come to the elicitation, collect the requirement or gather the requirement. Then we will come to elaboration, where we will create analysis models. So we will create some basic models at the time of elicitation, and we will create more rigorous models during the elaboration, because we will be analyzing it and we will represent all these information, functional behavior of the aspects of the requirements or aspects of the product that we are going to build. And then we will have to finally make some negotiations, because there will be conflicts. There will be some unrealistic requirements, so we have to make some negotiation. We have to discuss with them, and then we will finally do the specification. And once the specification is established, we have to do the validation. That means we have to review it. We have to check it that it is complete. It is not. There is no ambiguity. There is no omission. There is no conflict. It is denoting the actual scenario, what the requirements are required by the issue. And finally, once it is over, we have to manage the changes. So we can look at it, each one a little bit more detail. So the first one is the requirements inception, where the initial aim of this particular requirement inception is to create a preliminary communication, collaboration between the customer and the developer. So that this kind of a communication channel we have to establish, so that we can get the requirement from them. So we have to identify the stakeholders. So there will be 2 types of stakeholders. One who are users related, either they are in the customer's organization or they're even external to the customer's organization. And then there will be more who are in the developing team itself, in the software engineering team itself. So they can be part of the team, or they may be part of the developing organization, the project organization, but outside the team. Maybe some kind of a support team. And we have to ask context-free, very general, high-level questions for the basic understanding of the problem. The people who will use the solution, what is the nature and behavior of the solution that is desired, what is the basic problem that you are having, what you really want to solve, and what is the performance that you are trying to get, how it will benefit your business. So that kind of basic high level, top level questions, context free. That means it is not very contextual to the development of the software. And questions should help the stakeholder to take interest in the software so that they will start providing you accurate information, because this is only the beginning. And it should provide to measurable benefit to the successful implementation of the software. Next, we come to the elicitation, where we try to actually collect the information from the stakeholders. So we have to, the meaning of elicit is to obtain or extract or collect. So there are different methods that we will be using to do this thing from the customers, users, and the stakeholders relating to the problem area. So what are the type of activities? Are finding out the objectives of the product, what the customer is looking for, how the product will help in meeting the business needs, how the product will be used. So what we asked, the same questions we asked in the Inception also, but here we are going to individual stakeholders. There we are going to some top level people, but here we are going to some individual stakeholders, and for every type of help stakeholder. So that is what we have written here. For every user, every type of stakeholder, we have to get this, because as we have said, that different stakeholders may have conflicting requirement and conflicting different expectations. So we have to go detail into each person and get this information. And that is why it is often called as the requirement gathering activity, because we are trying to collect things. And sometimes it becomes very often difficult because of problem scope, understanding, and volatility. So let's look at what are these problems. Okay, I think I don't have that slide. So first of all, that we have to see that the scope, we cover the scope. So that is one of the problems, that we only go into those things which is within the scope, but not outside the scope. Then understanding may be difficult, because as we have seen, there is some difference between the way software engineers speak and the way business people speak. And volatility is there because it keeps changing. So the requirement may keep changing. So by the time we have collected it, later on it may change. So that is another problem in getting the requirement. So we have to understand, we have to keep it in mind that this may happen. So we'll go to the requirements elaboration, which is the third phase. As we have said, it is more of analyzing. So the objective here is objective is developing a refined model. So whatever initial requirement we have gathered, that we will analyze, and we will try to create some refined models. So we'll see what those models are. These models will be basically providing us the software functions, features, and the information domain. They will tell us more about the functions, features, and the information, also the constraints. So we will have to do the analysis of the information that we have gathered during the inception and elicitation. And these models will help us clarifying the requirements for the design activities. There are the tasks that are taken up are modeling user scenarios, modeling use cases, and the events in the scenarios and use cases. These will be parsed and extracted, and then at the end of it, what we will have are some models. These models will provide us informational information, they will provide us functional information, and they will provide us behavioral information about the problem. And that is why this activity is called the requirement analysis. I think in the next class, we will be going much more details into the elaboration. Requirements negotiation is basically because we have to prioritize the requirements. This is a major area of focus, and we will also look for some conflicts and any clarification that has to be checked, and we will look for the correctness. Any relationship among the if they are related, then we have to understand that more. And requirements will be categorized and prioritized based on the customer needs. So there's some value, business value has to come out. And requirement are carried out with the customer to fix the project scope, cost, and timeline. So once the negotiations are over, that means we know what has to be finally developed. And there is no winner or loser. We should not think that customers are different from the project team. They are a single team. Then we will go to the requirement specification. Now we know what we are about to do. So we will be basically creating a document which can become the base for the design. So we have to go to the graphical models that we have created. Whatever are the graphical models we have created, we might have created some process document text and some descriptions, and some mathematical models also we might have given, because some algorithms will be there, and all the scenarios, user scenarios that we have collected, all these things together, we might have created a prototype. All these things together, combination of some or all of the above, will be part of the specification. And it has to be a very formal, and the size will vary because it depends on the complexity and the size of the software. And for large systems, we need to have written document and proper descriptions and graphical models. Everything has to be there. For small systems, we can directly go from the usage scenario. That may be sufficient. Or if we are going in increment for smaller scope, we can go for directly from the usage scenarios. Then this is something, the contents, if you have a written formal document, then how it will look, what it will contain. As we have already discussed, it will contain information content, it will contain behavior, performance, design constraints, how to validate validation criteria, because it has to be validated. That is one of the property of a good requirements, and any other information that we need. Then we will go into the format, so we can create a format with all these things. It will have the introduction, information content, functional description, behavioral description, validation criteria, and bibliography appendix. So in the appendix, we will create all the additional information that we will keep here. Bibliography will contain from where we have taken the materials, who all were interviewed, who all were collaborating with the team. So everything will be written down in a proper format. Then we will come to the validation. So whatever is the review specification we have made, which is the collection of textual and graphical and tabular, or whatever is the form we have expressed it, all those things will have to go into review. So we have to find the errors, if at all we have done. Even after the negotiation, we might have made some errors. So we have to sit together and do the formal technical review. And we have to look for correctness. We have to basically think of the good characteristics of the good requirement and check that our requirement is actually good. So we have to check for ambiguity, no conflict. We have to check for correctness. We have to check for completeness. That means nothing is missing. And we have to remove all inconsistency, conflicts, and more or less. And also we have to look for the realisticness, whether it is achievable in terms of the performance parameters and also in terms of the technical or environmental issues. And so we will have to have a specification review. So specification review, you can have 3 levels. One is the macro level. You can have a macro level where you are just looking for these top things. Everything is available. Then you can have a detail level where you will go into the detail of the information function and the behavioral domain and go into each of the models and check it. basically kind of executing it and testing it. Then finally you will also have to look into the language and the wording so that there is no ambiguity in the word. For example, there are some ambiguous words that people use, sometime, often. They are qualifying words, they are not quantified. So if you use such kind of qualified words, then it is not clear. It needs more clear. So sometimes, then when you say sometimes, you have to ask how frequently. Is it 2 times a week, 3 times a week, like that? So this kind of questions have to be answered, and this wording has to be removed. It has to be made more specific. And finally, after all this, the SRS has to be approved, or what is known as signed off. And once it is signed off, then it becomes a contract. So it doesn't become a contract actually in the legal terms, but it is like a technical contract between the customer and the team. And after that, any change comes, then that becomes a change request. And whenever there is a change request, because this is signed off, so whenever there is a change request, it has to come in a formal way, and it has to be evaluated, and it will definitely increase the cost and the delivery time of the product. So that is well understood between the team and the customer. And finally, we come to the requirement management. In the requirement management, we are basically monitoring the requirements that we have taken. So we will be tracking. So we'll be tracking for the changes, and we will also be tracking for the conversion. So these two things, conversion requirements to design and code, and requirements to its changes. So these two things we will be tracking. And we will also be using some traceability table that helps us in tracking. So let's look at how traceability table will have, what all the features it will have. The traceability table actually consists of multiple things. One is the feature traceability, which depicts how requirements relate to the features observed by the customer. Then you will have source traceability, that means from where this requirement was originated, how it originated. Then dependency traceability, that means whether there is any relation between different requirements. This is important because when you do the change management, if you change one requirement, the other requirement also will undergo change. So whatever design and code you have created, that have to be changed. Then subsystem traceability, that means if you have divided into subsystems, then you will need to know which will be tracked to which subsystem. And interface traceability indicates the relation of a requirement to internal and external interfaces. So basically, we have to maintain these traceability tables, and so that it will help us in managing the requirement. Now we will come to the elicitation of the requirements, because you have seen that inception is just the starting. So we'll start with the elicitation, and the next class we will be going over the other activities of the requirements engineering. So there are 3 important methods. One is called collaborative requirement gathering. The second one is called qualitative function deployment, and the third one is the user scenario. Under the user scenario, today we will cover use case diagram, and later on there are activity diagrams also, which are also part of the user scenario. But that we will cover with the elicitation, with the elaboration activity. So coming to the collaborative requirement gathering, the objective is to obtain a preliminary set of product requirement. So there are some basic guidelines how to conduct it. So you have to conduct it through meetings, and there will be some rules. We have to establish some rules. We have to establish some agenda. It has to be very formal, and there will be one facilitator who will be controlling the meeting. Who will be otherwise it will go uncontrolled. So somebody who should be conducting and controlling the meeting. Then we can use blackboards, flip charts, and stickers for the discussions. It has to be in a very collaborative, non-threatening. This N is missing here. So non-threatening attitude. in that atmosphere. And it will not be a single meeting, but there will be some follow-up meetings. There will be some demonstrations, and we have to also collect the records, and more meeting and interviews will follow. And after the initial list is prepared, preliminary requirement list, you can divide it into sub-teams, and each sub-team will work to develop what is known as a mini specification. And these mini specifications will be presented, and whatever are the comments that has to be incorporated into it. Then each sub-team will create a validation criteria, and then someone has to add all the sub-teams draft into a single complete draft specification. Then comes the next one, second one, which is known as the quality function development deployment. It is a technique that converts business needs of the software of the customer into more technical requirement for software, and objective is to maximize the customer satisfaction. So it's a very old technique. Sometime in 1990s it was suggested. Basically what is done is it emphasizes what is valuable to the customer. So we have to provide a value to each requirement. So throughout the engineering process, we have to think of the value to the customer, and that is why it is called quality function. How much quality does the customer allocate to it? It is carried out by using structured. Again, there are structured discussions over meetings with customer representatives, because customer has to be involved. They have to give the requirements. So finally, after we have done this valuation of the requirements, we have to prioritize it and categorize it. This categorizations will be either you can call it as normal, expected, exciting, or you can say must have, should have, and like to have. So what is normal requirement? They reflect the objectives and goals of the required product that makes the customer satisfied. This is the minimum that needs to be given in the software. And all these functions, system functions, graphical display, there's some of the examples. Expected requirements means that customer is implying that this will be there. They don't say it, but they mean it. When they say a certain functionality in the normal requirement, they also imply some more requirements. So this has to be extracted from them by a proper kind of negotiation and discussion. So for example, the user interface is a normal requirement, but that it is user friendly, what type of friendliness they will need, what kind of help they will require, that is the expected requirements. Similarly, outputs, they will give you the outputs, what is the output will come, format of the output, but that it has to be accurate each time they run it is a part of the expected requirement. Similarly, operational ease, reliability, performance, speed, all these things are expected requirements. They are non-functional requirements. Then there are some exciting requirements, or like nice to have features. They go beyond the expectation. They make the customer elated. So if you can give this, it is good. But if you don't give this, the customer cannot say that I am not satisfied, because the basic requirement is already satisfied. So for example, when they ask for graphical display, you also provide choice of graphs. Instead of giving single graph, whatever they have initially you also give them choice, so they can choose which graph. Complex UI, drop-down list, help messages, so on and so forth. So how it is done, this is an example. You can have an initial meeting, then you can examine the past, you can identify some of the requirements in the initial meeting, then you go back and discuss with them, interviews, survey, you take their data, their problem reports, past records, everything you examine. And then you have a set of meetings with all the data that you have collected, and you create some kind of a good document, structured document for each functionality. You try to give a value, maybe in a 1 to 10 scale or something, and data, objects, events, information deployment, all these things also you try to find out to the required function. So whenever each function, what is the data objects that they will be required, what are the events that will trigger it, what will be the relations, all these things will be discussed. And the complete behavior of the system will also be discussed. So three kinds of things: the function, the information related things, and the behavior. And you will finally do the value analysis. Based on these three things and the score that they have given, you will do a value analysis and finally categorize the requirements. Now we come to the third one, which is the user scenario. In this we said we will discuss the use case. So what is user scenario? Scenarios are basically usage threads or action flow of the system by different categories of users. Each user uses the system in a different way. So how do the user use? What function they carry out? Okay. And as such a use case scenario, it's like a story. A person is interacting with a system. So he's giving something, he's taking something. And these persons these external people or something who are actually interacting are known as actors, and because they interact with the system. And so you create a set of usage threads. Okay, and this you do when in your collaborative meetings with the customer, you try to take out all these usage threads. And these usage threads are called user scenarios or use cases. In what case they use the system. Each scenario is depicted from the point of view of the user. You have to understand that this is a user's view of the software. And the user here is the actor. So that user can be an actor, a person, or a role, or a device, or an external system. So because we are making a generalize, so there can be another system which is interacting with your software, or it can be a device which is interacting with your software other than the human beings. So what are the use case components? What does it contain? So once we have received all the user scenarios, we have understood the user scenarios, we have to create two things. One is the use case diagram, and the second one is the use case description. In the use case diagram, we will have the actors who are the external device or people, and we will denote them by a stick man in the use case diagram. And there will be use cases which will be denoted like an ellipse. And they will be basically the functionality, the sequence of interactions that they will do, that the actor will do to satisfy the functionality. And that will be summarized as a single bubble initially, as a single ellipse. And then the association between the actor and the use case will be there. This will be denoted by a solid line. We'll see some examples. And a use case model, when we say a use case model, it will include all use cases of a system. So you just think of it, if there are multiple roles or multiple users, each one doing multiple functions, so there will be so many use cases, and all the use cases together we will say is the use case model of the system. And then we will have some use case description, because the diagram cannot give you all informations. So this is the example. There will be stickman, passenger, and purchase ticket is the name of the use case. So that is denoted by the ellipse, and this is the association stick. So that is what I have written here. You can read it from your notes. So a use case normally will consist of the unique names, participating actors, entry condition. There will be an entry condition, there will be a flow of events. So when he does this, what is the flow of events within this participating actor? What are the flow of events? And under what condition it will exit? And if there are any special requirements. So in this example, we have the purchase ticket is the name of the use case, and the actor is our passenger, the stickman. And the precondition is that the passenger is standing in front of the ticket vendor, or that vendor can be a machine, and the passenger has sufficient money to purchase the ticket. And the exit condition is that the passenger gets the ticket. And the passenger will, this is the flow, normal flow, functional requirement. We said there will be event flow. So this is the event flow. And as you can see, 1, 2, 3, 4, 5 steps are there. And finally, he gets the ticket and he also gets the change. But this is only the normal flow. There will be some exceptional error flow also. So those things will also have to be included. Any non-functional requirements, any user interface requirements, and some kind of sample dialogues also has to be included so that this flow will be clearer. So the as you can see, it is because it is having both the diagram as well as a description. It is a very effective technique for communicating the system behavior. It's a behavioral diagram, the complete outside external behavior of the user of the system in terms of the user's view. All the externally visible system behavior, what the user will see, how the system will be visible to the user when the person is using it. And use case diagram illustrates the overall scenario involving functional requirements. Also, the detailed requirements will be there in the description, and some of the non-functional requirements. They can either be in this description, or there are other unified modeling language. UML stands for Unified Modeling Language. So UML diagrams, we will discuss that later. So some of the other things can be available, not in the use case, but that will be in the other diagrams. Now let's go into how to represent these use cases, because we have seen that we have taken the summary, only single bubble as one ellipse, but that is too big, because there is the normal flow will contain many steps and there will be so many other flow also. So what we have to do is when we see that a use case is complex and large, then we have to decompose it into simpler use cases so that it will improve the understanding and we can handle it, we can track it to the design. And this process of decomposing is called a factoring process. That means we factor it out, just like in mathematics we have read factoring. We create the least common factoring and GCF, all of you have done it. So like that we factor these use cases, bigger ones into smaller ones, so that the smaller ones together it will represent the bigger one. Factored use cases may display common characteristics across several use cases. Sometimes when we factor it, we find that some of them are same. They are coming from different sources of use cases, but they are same. So then we can do the reuse. So that is another good use of the factoring. And there are three types of mechanism that is used in the factoring. One is called the generalization. The second one is called the includes. And the third one is called the extends. So we'll look into it one by one. So what is use case generalization? Here it is a parent and child relation. Just like in a class, you have all have done object-oriented programming and object-oriented codes you have written. And you know that when you define some classes, you define some higher level classes, and then you define lower level classes which are derived, which inherit the properties. They are child classes. So similarly, you can think of a parent use case and a child use case. So child use cases can be used when they have similar function but something different. Say for example, when you are doing the transfer of goods, you can do the transfer of goods by truck or by train. So these two property is different. But whether you do this or you do this, basically you are transferring goods. So this will have all the property of transfer of goods. This will have all the property of transfer of goods. You don't have to rewrite it. Only you have to write the special things for train and the truck. So however, the base and child class use cases are different. So you have to describe this separately. So you have to give the description of each one separately. And this is another one: pay fees, pay by library card and pay by credit card. Then we come to the second one, which is the extends relationship. So in the use case generalization, this was a parent and child relation where we use the inheritance. And here what happens is there are exceptional behavior of a use case. Say, for example, in this particular case, when you are trying to do the purchase ticket, when a passenger is purchasing the ticket, so getting the normal, having the change and being able to get the ticket is the normal flow. But sometimes the vending machine may be out of order. Then what happens? Or at a stage, the customer says, no, I don't want to do it. I want to cancel the ticket. Or there is no change in the vending machine, or the machine gets timed, the system gets timed out. So these are things which are not normal but some exceptional, and they will not occur every time. Under certain conditions only they will happen. So there is no need to add all these things into this and make it very bulky. Rather, we will factor it out into smaller sub use cases and call it extends. So what happens? The direction of the extend relationship is to the extended use case. That means purchase ticket is extended for all this, but the arrow will be on the other side. The arrow will be towards the base use case. And unlike generalization, this will always add the different behavior only when certain conditions occur. They are all conditional occurrences, under conditional behaviors. Whereas in the generalization, we did not have conditional. We had just additional because it's a child. Then we have the third one, which is the includes relationship. In the includes relationship, what we do is there are multiple bigger use cases which have certain common things. So when we analyze this use case, we find that checking of the user ID is part of the user login. Similarly, changing password also we need a checking of the user ID. So what we can do, we can factor out this one from these two, take it out, so that this one will become lighter and this one also will become lighter, and this will be common, and this use case can be included in each of these. So here user login includes checking ID, and this also includes. So the direction of the include relation is to the using use case, and the arrow is from the base case to the common use case. So these are some more examples of extended use cases: invalid data, out of stock while issuing the material, and making payment, pay by card, pay by cash is a parent to child generalization. This is another example, usage of passenger ticketing. Here I have shown both includes and also extends. So collect money is extended to cancellation, and these are the alternate paths, whereas these are the common paths. So collect money is the reusable use case. This one you can read on your own. This is another example. So how to organize these use cases? You can create system boundaries because you have your use case model contains many use cases. So you need to organize it some way. So you can create a boundary box, a rectangular boundary box, and say this is my scope for the system. So this is one way of organizing it. Otherwise, you can keep it like folders, packages. They are called packages. Packages are depicted as file folder, just like we keep our data in our computer. So you create, you take a set of use cases and put it as a folder. So in use case package is a collection of use cases with actors, relationship diagrams, and other packages. So this is an example. You have a university information system with 3 actors, 1 professor, financial. In fact, I have four actors. I wrote it wrong, correct? There should have been 4. Professor, scheduler, financial administrator, and a student. And each one has a different thing, but then student has to manage fees. So all the use case that is related to managing of the fees can be put in one folder. And similarly, enrollment can be put in one folder. And professor has to manage the courses or the seminars, so that can be put in one folder. And if there is somebody who is preparing the routine, the schedule, then that fellow also will have to interact. So there will be 2 actors, 2 different roles to this particular one. And there will be some financial administration that will manage all the fees and the loans and grants. So like that, you can organize your use cases. So use cases are very useful for determining requirements, communicating with clients, and generating test cases, because finally we have to validate the specifications up to the design and construction. And what will be the work products from the elicitation activity, because so far we were discussing the methods of how to do the elicitation. So we have looked into 3 methods. So use case was the third one. So now when you complete your elicitation, you will be coming out with the output or the work product from the elicitation. So you will have, in general, it will contain all these things: statement of need, feasibility, statement of scope, list of participants, description, list of requirements associated with the domain, list of usage scenarios, use case. This is basically the most important one every software engineer is looking for. And then finally, you can also have some prototypes. Suppose in case you have developed some prototypes to clarify your requirement, because it was very difficult. We have already discussed about the prototyping in the process classes. So let's look a little bit more about the prototyping as part of the elicitation. So there are 2 types of prototypes we had said. One was the throwaway. Normally prototypes are throwaway type, but then you can also have a evolutionary or an open-ended prototype. So that's why I have shown these 2. So let's look at each one. In the evolutionary prototype, actually this is relevant when you follow the agile approach, because we are trying to create the system in a very accelerated manner, rapid delivery, and we are not doing the full system, but we are doing it in increments. So we are rapidly delivering small increments of the system. So in that case, whatever is the software that we develop is like a operational prototype. So here we are creating the operational prototype and we are delivering it. But the problem here is, so this is the kind of flow it will follow. We have seen it. We have already discussed this kind of thing in our process class. When we discussed the process, the agile process, we have seen this. Okay. And the problem is the maintenance management and the contractual. So we will have management problems, like we will not have the skills. We will not be able to estimate, because most of the estimations are the kind of a waterfall model. Management processes are defined for the waterfall model. Then there'll be some maintenance problems, because the system architecture and design is not optimized, and they are not meant for scaling. So some continuous problems will come up, and we have to continuously do refactoring. That is what we have discussed in our process class, in the agile class, last class. And also we will have contractual difficulty, because we will not be able to, because the management process is not well defined for agile, for this kind of evolutionary prototype. So estimating the cost and timeline will be very difficult. Throwaway prototypes are easier, because we have done it only to understand the requirement and to remove the risk. So reduce the risk we have used, and this is our similar to our prototyping process model. You have seen that prototyping process model we have seen in our evolutionary methods. Okay, so you will follow that. So this is the kind of diagram I have given. It is similar to your process class, slightly maybe different. And these are not designed. We are taking just a very light, very small requirement, few requirements, limited requirements, which are very important, which we want to try out, which we want to clarify, which we want to try out and remove the risk. And they are not designed for long-term maintenance. They are made rapidly by using a lot of simplifications. We used simplification. We used some tables and some tools, 4GL tools, which cannot have the strength of continuous execution. So that is why these are throwaway. So we do it, we validate the system, and then we throw it, and then we take the actual requirement and we build the system again. So coming to the end of the lecture, today's lecture, We have seen the requirement engineering, why that it is started in the communication activity in a generic process framework, and it is one of the first technical activity because it starts in the communication phase, the initial phase, and it is in the prescriptive model. It is and it is normally called as the requirement analysis and specification. You have seen the waterfall model. We called it as requirement analysis and specification when we went to the prescriptive models, and all others we called it a requirement analysis specification. And it has 7 phases. All these phases, whether we call it this or we call it RE, we will follow this kind of method. And during inspection, key stakeholders have to be identified, and the collaboration has to be created. And we saw that there are 3 methods. One was the collaborative requirement gathering, one other was the quality function deployment, QFD, and the other was the use case modeling. And use case modeling is a system's external behavior diagram. There are other behavioral diagrams which we will deal with later. This is the first one, which gives the system's external behavior. In the UML, in the UML, it is called, and it is a user's point of view. So it is called as a user's view of the system. And we have also seen that the work product that we take out contains the prototype. So we have looked into the prototype, and we have seen how the prototype looks like, and whether it can either be a throwaway or a evolutionary type. So I'm just looking into your questions. Well, there is only one question that how we built the prototype. Okay, that's a good question. So I will possibly go back to this. So you can see it here. You get the outline requirements. You don't take the full requirements. When we did the prototype, we only take only a small amount of requirement. And most of the cases, it is not well defined yet. It is very shadily defined. It's just an outline. Where is my cursor? Here. Okay. So this outline we have to, by using the prototype, we have to actually clarify this. So how you develop the prototype? So that is your question. So what I told that you have to use a lot of simplification. First of all, you have to use some 4G languages, okay, or you have to use some already available library function. Nowadays, a lot of things are available. You can get it from JIT or any other source. Even Java, Ruby, everything, they all provide a lot of functions. So you take this, whatever you call it, DLLs or whatever you call it. So you take these. And then also, normally we develop prototypes for user interface. Normally, user interface is a good thing to create the prototype through the user interface. So you create a lot of screens and you create the screen flow. So you have the screens, and as you know, screens, there are a lot of tools. Very easily you can develop the screens. So at that point of time, you are not writing the server code. So whenever you have a system, you have the front end and you have the back end. So when we create the prototype, we are not writing the actual backend code. We are only creating a screen, very simple way, a screen flow, so that the screen will flow from one place to another place. But the internal code, the server code or the intermediate code is kept very simple by using either some function or some known thing, or specify example, suppose it has to go to a database and get some data and validate it or make some calculation. So what we will do, we will create a table, a data structure in the program, and it will have the answer. Actually, it will be a lookup. So we know it will not serve every user entry. Only for limited data entry, we will create a lookup table and give the answer. That is why we said that is why it is poorly structured modules. They are not the actual ones. Similarly, all the computation, you really don't need to do everything. You can simplify it. Even the computations you can put in a table. And say, for example, suppose it is calculating some salary or some interest. So you can put that. You can say I will have for 1,000. What is the interest for 2,000? What is the interest? Like that you can put. So you give those input. You don't give every input, because this is like a toy system. A prototype is considered as a toy, something with which we will play. We will try it out with the customer. We will keep looking at it and run it, execute it. The idea is that the customer will now understand how my system will look, and the customer will provide us the actual requirement. Then what we will do each time, so that is why we are developing the prototype very fast. Then we are going to the evaluation. This is where the customer is running it and giving us the feedback. Then we will come back. There is a backward arrow here, and we will redevelop it. And this one will go on iterations until the customer is satisfied. When the customer is satisfied, he says, yes, this is what I am looking for. By that time, all your computation, your database, everything is already understood. And then you can specify the system. Now you can create your models. Now you can create your SRS document and everything. So you don't need this prototype anymore. So you throw it. You have got this. Okay. And if you have developed some reusable components, you take it from here, and from the system, specify the system goes. Then you develop it. Means you start your design process, and then you do your coding, and then you do your testing. So here the prototyping is over. I hope I have answered your question. Can we use a 3D printer? I don't know how you can use a 3D printer for a prototyping, because 3D printer is, as far as I have my knowledge goes, 3D printer is used for a physical thing, something that you are designing physically. But a system is not physical. A system is always abstract, which will run on a computer. So I don't think you can use a 3D printer for it. 3D printer doesn't come into picture. We have human beings who have to be interviewed, model has to be shown, a prototype has to be shown, a running prototype, which the users can execute, and they can come out with the requirements. So here in this particular lecture, our focus is on how to get the requirements properly. And we have gone into the first two steps, that is the inception and the elicitation. And we have looked into the methods that we will use in this. Well, there's another question. Is it possible to make all things prototype? Not really, because as you see that prototypes are throwaway. So I don't think prototype is the right answer, because finally we have to produce the product. The product will stay. The product will continue to be maintained over years. Suppose a person takes 6 months. A team, software engineering team, takes 6 months to develop a software, but the software will live with the user maybe 10 years, or maybe 5 years, or maybe 6 years. So for that 6 years, 5 years, it will be maintained. So a prototype is a very small thing to be maintained over years. So a prototype is either used in the evolutionary method as a first delivery, as a working software. So each delivery, you can call it as a prototype. So if you are doing a agile method and you are giving incremental delivery, then each working operational software, you can call it as a prototype. But normally in the software engineering terminology, it is not called like that. It is called an increment. It's called a sprint, in which we are giving an operational software. The first one is normally called as the prototype, because that is the first one which they look into it and they provide the proper feedback. And based on that feedback, the other increments are made. So prototype is only the first small build. It is not the complete product. So I don't see any other question. So I'll be sharing some of these notes, and as I told you, some MCQ also I have shared, but I don't think it is already up. So I'll see that it is up and it is given. So we have already gone into it and we have already answered the doubts. So thank you all for listening to my lecture. And if you have further doubts or anything, we will see how it can be solved in the subsequent lectures, because next lecture I will be covering the other methods other modeling that we use in the analysis or in the elaboration of the requirements.